Good morning or afternoon, actually. I'm here early this morning to make you guys this video. I meant to have it for you yesterday, and I apologize. So we're going to graph some parabolas and shade. The first one, by the way, this is your notes, lesson 3.6 that were handed out yesterday. Look for extra copies in the blue box if you don't have one. Follow along and fill this in if you didn't yesterday. This is vertex form that we're in. And remember that the vertex would be the opposite of this number with the back number. First, go plot that and draw your parabola. This is going to have a stretch of 3. Those 3 points are probably enough for the shading that we're going to be doing. But if you plotted another point, actually 2, 4, 3 with a stretch of 3 becomes 12 tall. And you do have enough room to get one more point up there if you wanted. We've sketched it. Now we're going to shade on or below the parabola. So on, because it's a solid line, meaning every point on the parabola is a solution to the inequality. And we're shading below because this is less. And so below the parabola becomes everything outside the parabola. And you don't have to shade the whole entire coordinate plane. It's kind of overkill. And this would be your result. And this I didn't mean to leave on there. We're not going to state the interval of x that's shaded. Okay, the next one. You have to isolate y first. So if we divide everything by a -1, we're going to get a positive y, a negative x squared, plus 4x minus 1. All signs change, and your inequality flips over. And that has to do with orders going in the reverse order when they become negative. And so everything that used to go forward now has to go backwards. Everything that was greater than now has to be less than. This is in standard form, so the only way we're going to get it graphed is to identify the vertex by first starting with our axis of symmetry. B is a 4, so we go -4 over 2 times A, which is -1. -4 over -2 becomes a 2. Dash in your line of symmetry if you need it, and plug that 2 back into just the expression. Leave that negative out front, plug in a 2 and square it. Take it times a 4 and minus 1. Square this first, keep it a negative, then plus 8 and minus 1. Combine the first two numbers first, and 4 minus 1 becomes a 3. That means your vertex is at 2, 3. Go plot that. This needs to be upside down in the parent shape because our value of A was a 1. So 1, 1 and 2, 4. And also our y-intercept of a -1 landed just right on that y-axis. This parabola is solid also because it has the equal to bar under the inequality. And we want to follow the shading of our new expression that flipped over. And now this says y is greater than the parabola or shade above the parabola. Okay, number 3. This is in intercept form, and it looks like it's going to be the parent shape. We're going to shade above it. So the x-intercepts are opposite of what you think. 2, 0 and 5, 0 get plotted. Halfway between them would be 3.5. That is like our line of symmetry. And if we want to find how high our vertex is, I mean, it's kind of hard to do with a halfway number to use that 1, 1 and 2, 4 pattern. So my preference would be to just plug in 3.5 to the original expression. You ignore y for a second. 3.5 minus 2 is 1.5. and the other one is -1.5. And I'm going to change these to decimals to multiply them because I actually know 15 times 15 in my head is 225, but if I multiply two decimals together, I have to put their place values back in the number, so the answer becomes -2.25. And that's going to be kind of hard to graph. You're just going to eyeball it. So on your line of symmetry, down 2.25, mark a dot, call that good, draw in your parabola that is supposed to be solid again, just double checking. It had the bar under it. This says greater than, so we're shading above the parabola. And this time that means we are inside the parabola. And that shading, just like the parabola, goes on infinitely. Okay, number 4. Is this the same exact problem as above? Oops, meant to change that one. Okay, call it a skip. Okay, turn your paper over and go to number 5. Now we're going to graph 2 functions at a time. This makes it a system of inequalities, and we'll shade the region that satisfies both, but we really just take one at a time. There is no squared in this, which means it is a linear function. That means we're back to thinking about a y-intercept and a slope that would be in front of our x. So the line would have a y-intercept of 1 and a slope of 1 to 1. It's solid because it has the equal to bar under it, and make it fairly long with arrows on both ends. Let's get that shading done first, and it's a less than or equal to sign, so we shade below the line. I'm going to do it lightly because I still have to graph my parabola. The parabola is in standard form, but let's see if we can factor this instead. The numbers are pretty small, and I think there's a connection between using the factors 3 and 1 and coming up with that -4 in the middle. So we should guess and check that it is x minus 3 and x minus 1. Double checking that middle gives you -3x. The outers give you -1x. That means this is factorable, and it's a lot faster to graph your x-intercepts at 3, 0 and 1, 0 than to do the -b/2a formula. So plot 3, 0 and 1, 0. This is the parent shape, and it's upright, so we know the vertex has to be 1, 1 away. If you want to go ahead and plot your 2, 4 points. And this is the first time we're seeing a dashed parabola because there is no equal to bar. And last, where do we shade? It says greater than the parabola, so I need to shade above the parabola. That makes it inside the parabola, and then all of a sudden we start to see that they share this, where I'm below the line and above the parabola. You darken in the shaded intersection, which means all points in that region are solutions of both. In other words, of the system. What it means to test a point, we would look for a point inside the shaded area. I think this one would be about the ordered pair 2, 1. You can confirm that that point is a solution by substituting x and y numbers 2 and 1 back into both of them. So heading back up to the top real quick, y is less than or equal to 2 plus 1. Oops, x plus 1 to start out with. Then sub in your 1 for y and your 2 for x. This now reads 1 is less than or equal to 3, and that's correct. It's true. When you check your parabola, I'm recopying the function down here, greater than x squared minus 4x plus 3. This time plug in your 1 for y here, your 2 for x. Do a little bit of order of operations on that. And then we'll clean it up and see if 1 is greater than the number we get. This would become 4 minus 8 plus 3. Next becomes negative 4 plus 3, or a negative 1, making this statement true, just like this statement was true. So since the ordered pair 2, 1 satisfies both inequalities, you confirm that you shaded in the right intersection of the shapes on the coordinate plane. Okay, last one, number 6. This time we're graphing 2 parabolas. This one's in intercept form, so we can see that our x-intercepts would be negative 1, 0, 2, 0. Gonna go plot those first. They also have a halfway number for their axis of symmetry, so I'm gonna have to plug in a half. Oops, not like that though. A half plus 1 and a half minus 2 leaves us with, I'm going to make this 1.5 look like a 1.5. And this one is a negative 1.5 again. Those often will match like that. And if you remember from the previous one where we got those, negative 2.25 is what you get when you multiply those. So now you know where to plot your vertex on your line of symmetry. This parabola should be solid. I'm not going to graph any more points because of that half situation, and 3 points gets the job done. We should shade above this parabola, so I'm just going to very lightly tell myself it's inside the parabola. Now go graph the second one. And I want to double check. This one might be just like the one on the front page that we already graphed, that had a negative x squared plus 4x minus 1 right here. And if you remember, we've already done the work for it. We know the vertex of that is at 2, 3. So we're going to just steal this information off of number 2 to graph this faster. So to the right 2 and up 3. This is why you want your shading to be very faint so that you can still see some ordered pairs. And that was an upside down parent shape graph. It needs to be dashed because there isn't an equal to bar under the inequality. And it says shade less than, so that is shading below. And if I do that very lightly and zoom in and take a look, I can see where they're shaded together would be this little chunk right there. The easiest point to test on this one would be 1, 1. It's in that region, but to save time and make this video short, I'm not going to do it with you. The last things I'll mention down here, make sure you have a solid boundary when you see those equal to bars, and that you dash when you don't have it. Shade above when you see the greater than symbols, shade below when you see the less than symbols. And if needed, you test points that are easy, like 0, 0, 1, 1 if they're available. We used a 2, 1 because the numbers were small. And when substituted into both, they have to make the inequality true. If a point doesn't make the inequality true, that's where you should not be shading. Now, work on all missing work or the worksheet 3.6, numbers 1 through 6.